Okay, today we're going to finish up our section on geometric sequences. Remember, our explicit formula was to take the first term times r to the n minus 1 power in order to figure out our nth term. And remember, to find r, we can take any term and divide it by its previous term. So we typically will just do second term divided by first term. But you can use any consecutive terms in your sequence. Remember, our rule of thumb is to identify what pieces we have and what we are still missing. Then we can plug everything we know into our explicit formula and use it to solve for the things that we are still missing. For each of the following, write an explicit formula for the arithmetic sequence, that should say geometric sequence, and find the sixth term. So we have non-consecutive terms. We know the first term is 3, and we don't know the second term, but we know the third term is 12. We can use that to still figure out our r value. If we think about our explicit formula, if we consider this our nth term, then n would be 3. So if we plug a 12 in for a sub n in our formula, then we're implying that our n value is a 3, since we're using the third term. Okay? We do not know our r value, but we do know that our first term is a 3. So to solve this, we need to divide our 3 over. So 12 divided by 3 would be 4. And then on the right side, all we have left is r to the 3 minus 1, or second power. So then we can simply square root to figure out our r value. Now technically, r could be either a 2 or a negative 2, since when we square root 4, we get positive and negative 2. And we do not have enough terms in our sequence to determine if we are multiplying by negative 2, where our numbers would alternate sign, or if we're multiplying by positive 2, where the numbers in our sequence would all be positive. So we actually can go through this with either one. So we have our explicit formula, and now it's asking us to find the sixth term. So let's go ahead and plug a 6 in for our n value. All right, so we know our first term. Sorry, let's go back and actually write out our explicit formula. We have a first term of 3. Our r value is positive or negative 2, and we're raising that to the n minus 1 power. So that's how we're going to find a sub n. If we want the sixth term, we would take 3 times positive or negative 2 to the 6 minus 1, or fifth power. All right, so let's look at our calculator. We want to take 3 times 2 to the fifth power. All right, we get 96. If we take 3 times negative 2 to the fifth power, we just get negative 96. So our sixth term could be positive or negative 96, depending on how we've defined r. All right, let's look at our second example here. Our first number is a 2. We do not know the second and third numbers, but we know the fourth number is negative 54. Okay, so we know the first number, we know the fourth number. Let's use those to figure out our r value. If we think about our generic explicit formula, we know our first term is 2. We do not know r. But we know that if we use an n value of 4, we should get an answer of negative 54. So we're getting negative 54 when our n value is 4. All right? To solve this, we're going to divide the 2 over, which leaves us negative 27. The power now becomes a 3, 4 minus 1. And to find the r value here, we're going to have to cube root negative 27. And the cube root of negative 27 is negative 3. So we have found our r value, so we can write our explicit formula. A sub n equals first term times our r value to the n minus 1 power. And then we can use that explicit rule to find the sixth term. So 2 times negative 3 to the 6 minus 1, or 5th power. 2 times negative 3 to the 5th power. And we get negative 486. All right. For the next one, again, we're given the first term is 500. We're given the fourth term is 4. So our number is going down quite drastically, from 500 down to 4. So our R value is going to have to be something smaller than a 1. We're decreasing this. All right, let's plug in what we know. We know our first term is 500. We do not know our R value, but we do know that when we use an n value of 4, we get an answer of 4. All right, so solving this, we're going to divide the 500 over. So 4 divided by 500, that's going to be r to the 4 minus 1, or 3rd power. So to find r, we need to cube root this. Now, you can put that in as a decimal. You can actually take 4 divided by 500, or we can just type it in that way. So we need the cube root, which is under our math key, number 4. We want the cube root of 4 divided by 500. So our cube root is 0.2. So our explicit rule would say we take the first term, we're multiplying by 0.2 to the n minus 1 power. And then to find the 6th term, we have 500 times 0.2 to the 6 minus 1, or 5th power. And let's grab our calculators. We want 500 times 0.2 to the 5th power. We get 0.16. All right. Go ahead and pause the recording and try this next one, and then turn it back on to check your work. All right. Let's plug in what we know. We know it's geometric, so it has to fit this formula. Our first term is 250. And we know that this time when n is 5, we get 4/10 for an answer. All right, so we can divide the 250 over. So we have 4/10 divided by 250. That's going to be the same as r to the 4th power. So now to find r, we actually have to take the 4th root of this. All right, so we want 0.4 divided by 250 and take the 4th root. So under math, we can use that option 5, that generic root. We want a 4th root, and then we are taking, what did we have? 0.4 divided by 250. So we end up with 0.2 again. Now remember that with even roots, it could be positive or negative. So my r value can be positive or negative 0.2. All right. We want to write our explicit formula. So a sub n equals our first term, 250, and we could do positive or negative 0.2 to the n minus 1 power. We want to find the 6th term, so 250 times plus or minus 0.2 to the 6 minus 1, or 5th power. All right, 250 times 0.2 to the 5th power. So using the positive, we get 0.08 or 800ths. Using the negative, we would get negative 800ths. So my answer could be positive or negative 800ths. All right. So we had an arithmetic sequence a couple days ago when we were talking about arithmetic sequences. Recall that the middle term of any 3 consecutive ones was just the arithmetic mean, or the average of them. Well, we have something similar for geometric sequences called the geometric mean. And to find that geometric mean, we multiply two consecutive terms together, or sorry, the first and third term together, multiply those and square root it to find the second term, the middle number. Okay? Note that the geometric mean is positive by definition. While there are two possible values for the missing term in the geometric sequence, there's only one geometric mean. The geometric mean is one possible value to fill the geometric sequence, and its opposite is the other. So just like in the previous example, we could have had an R value that was positive or negative, so our sequence could alternate numbers or not. So use the geometric mean to find the following terms in the geometric sequences. So to find the second term, we are taking the first times the third, since it's geometric, think multiplication, first times third, and then square rooting that. All right? So we need to take the square root of 48 times 3. And we get 12. So our missing number here would be a 12. Or it could be a negative 12. Again, our geometric mean is 12. But our answer here could be positive or negative 12, since we don't know if that next term is alternating sign or not. Okay? Next one, our geometric mean. We're going to multiply the 2.5 and the 90, and then square root that. So we want the square root of 2.5 times 90, and we get 15. So our missing number could be positive or negative 15. All right, next one, it says a sub n minus 1 is negative 5 and a sub n plus 1 is negative 80. We are looking for a sub n. The previous number is negative 5. The number after the nth term, the n plus 1th term, is negative 80. So again, we're looking for that middle number. So we square root negative 5 times negative 80. We'll grab our calculators. We want the square root of negative 5 times negative 80. And we end up with 20. So our geometric mean is 20. Our missing term could be positive or negative 20. All right. Same thing for this one. Our previous number is 40. We're looking for the nth term. The number after the nth term is 3.6. All right, so we want to square root 40 times 3.6. And we get an answer of 12. So our nth term could be positive or negative 12. The 9th and 11th terms are 45 and 80. What is the 10th one? So again, we're given a 45, a missing one, and then an 80. And we're looking for that missing one. Doesn't matter where in my sequence it is. In this case, we're given the 9th and 11th, and we're trying to find the 10th. We still can multiply those two together, square root that answer to find that missing term. So we need the square root of 45 times 80. And we get 60. So our missing number, our 10th term, could be a positive or negative 60. All right, so you guys are going to be working on the rest of our geometric sequence information using worksheet 9.3b.